Lesson 2-3, Day 2, Solving Two-Step Equations. You'll need a little whiteboard, marker, and eraser for this lesson. We do not have a new essential question today because we're just going to have an extra practice day for two-step equations. As a review, we have one of each of the three main types of two-step equations. So in the class, we would have a volunteer come up and solve this. Our married couple would be the 2x because the 2 and x are attached to each other. So that would make the third wheel the minus 6. So we would need to get rid of that minus 6. The inverse of subtracting 6 is adding 6. So you add 6 on both sides. Then the result would be 2x equals 10. Now it's a one-step equation. 2 times x, the inverse of multiplying is dividing. So we divide by 2 to get our solution, x equals 5. Remember that you can substitute that 5 where the x is in the original equation to check and make sure that it balances. 2 times 5 is 10. 10 minus 6 does equal 4, so it checks. The second type of two-step equation is a big fraction, If you are struggling with remembering which step you do first, a couple of ideas. One would be that you might want to do the check, because then you can see if you've got the correct answer. Another idea is to think about how you would read the problem, like saying it out loud sometimes helps. N plus 1 is being divided by negative 2, and the result needs to equal 15. So my married couple is what I said first, my variable, n plus 1. That is my married couple. They are together on the top of the fraction in the numerator. So to get rid of that denominator, when you're dividing by negative 2, the inverse of dividing is multiplying. So I need to multiply by negative 2 on both sides, and that will clear my entire fraction. It will clear my fraction. So the result would be n plus 1, and it's now equal to negative 30. Then I subtract 1. The inverse of adding 1 is subtracting 1. And I get my solution, n equals negative 31. Now, think about checking that. Where the n is in the original, if I put in negative 31 for n, this is what my equation looks like. The numerator would need to be simplified. So negative 31 plus 1 is negative 30. Negative 30 divided by negative 2 is 15. That checks. Negative divided by negative is a positive. The third example, notice that my variable, my married couple, is over on the right-hand side. So my third wheel is the negative 2. The negative 2 that was being added to x divided by 3. To eliminate that negative 2, I need a positive 2. A positive 2. That would be the opposite of negative 2. Negative 2 plus 2 is 0, so it cancels out. So I have 16 equals x divided by 3. The inverse of dividing is multiplying, so I can multiply by 3, and 48 equals x. I can check to make sure that it works. Plug it in where my variable is. So 14 equals negative 2 plus 48 thirds. 48 divided by 3 is 16, and 14 does equal negative 2 plus 16, so it checks. Okay, now in the classroom, what we would do next with those little whiteboards, markers, and erasers is we would have our students write their own two-step equation. So they're making up their own equation here. And we are requiring that the solution needs to be x equals 5. So write your own two-step equation that has a solution of x equals 5. We expect to see a lot of different types of equations for this. The most common is the two-step where you've got a married couple, like say 3x minus 1 equals, and if my answer has to be 5, I want you to think about substituting the 5 where the x is right now. 3 times 5 is 15, minus 1 is 14. Now, I have to solve it to prove that my answer is 5. So, 15 divided by 3, x equals 5 is my answer. So my equation worked. So my equation, write your own two-step equation, my equation again looked like this. 3x minus 1 equals 14. There are a lot of different ways you can come up with an equation that would work. Another one, let's say that you wanted to have a fraction. So let's say that I've got x divided by, that probably won't work out as easily to get 5 as an answer, but x divided by 5, and we could say plus 2. So think about if x is equal to 5, 5 divided by 5 is 1, plus 2 is 3. So, again, I have to solve it to prove that this works. So subtract 2 on both sides. X divided by 5 has to equal 1. Then I would multiply by 5 to cancel out my denominator of 5. And x equals 5 is my answer. So now I have another equation that also had a solution x equals 5. So there are a lot of ideas, a lot of options that you could use. So we expect to see some creativity in the classroom. The next one, now it's the same type of problem, only we've changed our answer. Now the answer has to be -3. So maybe your equation looks something like this. Maybe it's -2x plus 7 equals, and if I substitute x equals -3, -2 times -3 would be 6, so 6 plus 7 is 13, so I am going to go with 13 here, and then I'm going to check and make sure that it works. So, subtract my 7, my third wheel, -2x equals 6, divide by -2, and x equals -3. Perfect. So my equation was -2x plus 7 equals 13. You could come up with an infinite number of two-step equations here that give you -3 for an answer. This is just one of those that works. Okay, then we would have students write their own two-step equation with no requirement and trade boards with their partner to solve each other's equations. And of course we said be nice, because you really do want to try to give them an equation that comes out to be a nice integer answer. Otherwise, they will, I'm sure, pay you back with an equation that isn't very nice on the next round. And here are the homework problems. Not very many. It's just our second day, same type of problems that we solved yesterday. So on page 818, please make sure that you are on section 2-3, because that page has some review problems from all of the sections. Make sure that you are on 2-3. And then it's just numbers 7 to 14, 16, and 17.